Hey guys, Dr. Brown here with Kubo Math again, and I hope you're ready to jump into some factoring for Algebra 2. So let's get after it. So factoring is just what it sounds like. You're trying to reduce the equation down to something manageable by pulling factors out of it and organizing them. For example, in this equation you can see that common factors between the 2 and the 10 would be, between the 4 and the 10 would be 2, and between the a to the 4th power and a to the 2nd power would be a to the 2nd power. I could pull those factors out of that, and then we can use the distributive property then to redistribute those things we're going to put inside the parentheses to get the original equation. For example, what do I multiply times 2a to the 2nd power to get 4a to the 4th power? Well, 2a to the 2nd power times 2a to the 2nd power. 2 times 2 is 4. A to the 2nd power times a to the 2nd power is a to the m times a to the n. Recall the rule. And it's a to the m plus n. So it's a to 2 plus 2 is a to the 4th. Minus 5, so a negative 5 times 2a to the 2nd power gives me a negative 10a to the 2nd power. So this would be the factor reduction of the original equation. This one, the equation on the back of my shirt, if you can see that, is the way to solve this one to get all the way down to x, but we'll work on that in future videos. But right now, let's just factor a 2 out. 2 times x to the 2nd power gives me 2x to the 2nd power. And minus a negative 4x times 2 gives me a negative 8x. Plus 5. 5 times 2 gives me 10. So that's how I could reduce that one. But what about this one here? Oh, this one's a little bit odd. I have x terms in 3 of the groupings of the items, but I have 2 in 2 of them, but not all the rest of them. So let me just work with the x terms, or these terms first, and then these later. So I'm going to put a parentheses here, and that's what I'm going to work with. Okay, well, I need to be careful with this parentheses right here for the time being. So x, let me pull a x to the 2nd power out of this one. X to the 2nd times x to the 1st gives me x to the 3rd power. X to the 2nd power times 1 gives me x to the 2nd power. Now what about this one over here? Let's see. I'm going to pull the 2 out. So a negative 2. A negative 2 times what gives me a negative 2x? Well, just a positive x. A negative 2 times what gives me a negative 2? Well, a positive 1. Positive times a negative gives me a negative. You'll notice I have x plus 1 within both of these now. So now, the first time I ever saw this, I thought there's no way this is correct. Now I can group the x to the 2nd power minus 2 times x plus 1, and that's the reduced factoring of the original equation. Now I know me, I would probably argue with my teacher and say there's no way that's correct. And she would say, well, just use the FOIL method and go back and multiply these together. First times first, outer times outer, inner times inner, last times last, and see if you get the original equation. So let's do that. First times first, x to the 2nd power times x to the 1st is x to the 2 plus 1, which is x to the 3rd power. The outside is x to the 2nd power times 1, so that's x to the 2nd power. Inside, a negative 2 times a positive x is negative 2x. A negative 2 times a positive 1 is a negative 2. Oh, That's exactly what we had to start with. But it's not as so obvious to me that that's the way that would work. So practice, practice, practice. That's the key. Equation number 4, x to the second power plus 7x plus 12. This is a method that seems to be more common that people would use to factor. Draw a grid, and you'll notice I have a positive here, a positive. So what can I multiply together to give me x to the second power? It could be x to the second power times 1. Could be x times x. Okay, let's go with x times x. Now let's look at the last term. Let's take the factors of 12. Well, that's 12 times 1, 4 times 3. Both of those multiplied together give me 12. But which one of them, if I add them together, gives me 7? 4 plus 3. Okay, so let's say I want a 4 here and a 3 there. Now I'm going to multiply the diagonal. X times 3 gives me 3x. X times 4 gives me 4x. 4x plus 3x gives me 7x. X, and multiply the end terms. X times x gives me x squared. 4 times 3 gives me 12. And all of these were positive. X to the second power plus 7x plus 12. So now I can use the row and say this x plus 4 and x plus 3 would be the, and then I could solve for each of these if I had, let's say this were equal to 0 or some value. I could then solve for x in the results. But these would be factors back from the original equation. But let's FOIL it to make certain. First times first, x times x is x to the second power. Outside times outside, that's plus 3x. Inside plus 4x. And then plus the last, 4 times 3 is 12. So now I have x to the second power plus 3 plus 4x is 7x plus 12. So yes, those in fact did work. Now, our last equation. You'll notice, in this case, my coefficient was 1. In this new problem, the coefficient is 3. Oh, how to handle that? Well, let's draw our grid and see what happens. So let's just dive into it and work the problem. If we mess up, we'll back up and go at it again. Let's go with the same 3x times x gives me x to the 3x to the second power. Now what terms of negative 4, I could negative 4 times a positive 1. I could have 4 times a negative 1. You know, negative times a positive gives me a negative. Positive times a negative gives me a negative. I could have a negative 2 times a positive 2, or flip those around. Positive 2 times a negative 2. But all of those would be factors that would work. Now, you'll notice I'm going to go with negative 4 and 1. And the reason I'm going to do that is because I'm going to multiply this. 3x times 1 gives me 3x. X times a negative 4 gives me a negative 4x. A negative 4 plus a positive 3 gives me a negative x. 3x times x gives me 3x to the second power. Negative 4 times a positive 1 gives me a negative 4. 3x squared minus x minus 4 is what I wanted. Now the resulting answer is 3x minus 4 and then x plus 1 equals 0. Let me clean this up. Oh, well, if that's the case, we could, one or other of these, this could be 0. 0 times anything is 0. It could be that this one is 0 and I don't care what this one is, then it still would be 0. Or it could be they're both are 0. Well, they probably can't both be 0 because that x couldn't be the same number here. All right, so let's solve for that. 3x minus 4 equals 0. 3x minus 4 plus 4 equals 0 plus 4. So I've added 4 to both sides. These cancel. 3x equals 4. So I divide both sides by 3. 3's cancel. X equals 4 over 3. All right, let's work with the other one. Oh, this will be easy. X plus 1 equals 0. X plus 1 minus 1 equals 0 minus 1. So x equals a negative 1. Let's at least try the negative 1. Put it back in here. 3 times negative 1 squared minus a minus 1 minus 4. So negative 1 times negative 1, negative times negative is positive. So that's 3 minus a negative, which is the same as plus a positive. Remember, that's my kryptonite, that one there. So 3 plus 1 is 4. 4 minus 4 equals 0. So I know that is the solution. I'll leave this one for you to work out, but it is correct because I did this one earlier. These are just a few examples of factoring. In the next session, we'll repeat this and just have more problems to work because we need to practice this methodology of factoring with numerous other types of problems. So it's always a pleasure to talk to you. Remember, study, study, study. I'll say it every week because if you'll do that, you'll enhance your life and you'll make a better tomorrow for sure. So let's keep after this and we'll talk to you next time. Take care. Bye.